All right, this is a little bit lengthy problem. Know that they put these here intentionally to help you, even though it looks like it's cumbersome. If you can kind of follow the steps and catch what they're trying to teach you, it actually can be a really nice thing. And I'll point out, I'll make it explicit here what they are trying to show you. So we have three beans being selected from a jar that contains lots of white and red beans. Um, and so we're going to assume all of these have the same probability. In other words, there's a large number of reds and whites. So if we choose a red, it's not going to affect our chance of getting another red. Or you can even replace however you want. The point is the chance of getting any of these 8 is exactly the same. So that's one of their assumptions. So the first thing we want to do is look at event A. So there's 8 different possibilities with our 3 draws with whites and reds. And we want to get a white bean on the last choice. Well, that one got white, white, white. All we really need to look at is that very final bean. Is it a white or not? And these 4 cases do have white beans finishing out. So we're going to have a probability of 0.5 there. Here, and this would be 4 divided by 8, by the way. There were 8 equally likely possibilities. 4 of them ended with a white bean. Here, exactly 1 bean is white. Well, there we find a case. White, red, 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 white, red, 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 white. So notice we have 3 out of the 8 that have exactly 1 white. No more, no less. And that's going to be 3/8 or 0.375. And then we have a white on the last choice and exactly 1 bean is white. Now I could go through and check every one, although if I have to hit both of these, I'm really just looking for any place where I checked both of these, and I noticed that the only column I checked them both is right here. This is the only one that ends in a white and has exactly 1 white. Because if you end in a white and you only have 1 white, well then neither of the other 2 can be white. So that makes sense that this is the only time you would get them both. So again, visually I'm just looking for any place. Let's see, where did I get A and B? And the only time it happened was right here, which would be 1/8, or 1 divided by 8, 0.125. Okay, and we go down here. Suppose exactly 1 beat is white. So what they've done, they've narrowed our focus, just like we looked at in another conditional probability video. We only are looking at the columns here where exactly 1 was white. So these 3 columns are the only ones that are even on our radar at this point. And now, within these 3, we want to see where did event A occur? In other words, where did we get a white on the last one? And of these 3, this is the only one where it happened. So we'd have 1/3, or 1 divided by 3. So that was a conditional probability. It limited our scope. So probability of A and B divided by probability of B. Well, what was the probability of A and B? That's right there. That's that 0.125 divided by probability of B. Well, that's 0.375. You can set it up on the calculator. This divided by this is going to give you 1/3, or 0.33. Probability of A given B, well, that's what we did right here. Given B means we were only looking at these 3 columns, and if we are, the chance that A occurs, well, only one of those had event A occur, have a white bean on the last choice. So this was 0.33. And this is really what they want you to see here. So like I said, they're trying to get you to come to a point where you have some kind of epiphany, and maybe you do, maybe you don't. But you can see here that these 2 are indeed equal. And this is where, I think what they're trying to show is where the formula for conditional probability comes from. They want you to see it kind of in a step-by-step process. This is typically how we write conditional probability. The probability of A given that B occurs. But we can also break it apart into the probability of getting both of them divided by the probability of B. So 2 different kind of approaches to conditional probability there. We can check all of those. Let me, what did they say? Without a decimal point. They looking for 1/3 here? Yes, they are. That's actually a more, I like that better. I was trying to do fractions earlier and they were forcing me to do a decimal. These decimals are all correct. Let's see if they'll. So this whole time I was doing more than I had to. 4 divided by 8, 3 divided by 8, and 1 divided by 8. Okay. There we go. And again, don't worry about simplifying fractions.